question actually to you first. Are there any problems that you weren't able to do in homework 2 that you want me to start with them first? Okay, so I assigned this homework before. Let's start with the questions that you weren't able to do, because I don't want to work on all of them. And I told you, come with your questions. You should come with your questions to our virtual class, because this is going to be just solving problems with you, and you're going to follow the lectures on the video recordings. Any questions you want me to start with? You can write the numbers in the chat, and I can just look at that, please. Okay, number 2, Tülin said number 2 and 12. Okay, let's start with 2 and 12, and let's see if you may have any other questions. We can work on them too, as time allows. Let's see, why doesn't it open? Okay, it's opening now. Okay, so this question says, find the slope of the curve at the given point P. Okay, it says the slope and the equation of the tangent line, and the function is given to be -5, -9x squared. The point is 4 to -149, and then you're going to write the slope, okay, and you're going to write the part B in the equation of the tangent line. Now, I'm going to solve it on a different screen now, okay? Let me make this available for you. Okay, I'm going to just close it just a little bit. Let me see what I have here. Okay, I'm going to solve it right here. You can see my OneNote page, right? Okay, so I'm going to solve it here. All right, let me see. Where's the draw? Okay, so this is question 2. This is question 2 in the homework. I think 2, right? It's homework 2, I guess. Okay, this is like a heart here. Okay, so the question was y is equal to -5, -9x squared, and the point was given for -149. Okay. Tülin, is this the same question that you asked? I mean, the function may differ.
Yes, teacher.
Okay. And the question is the slope. Okay, that's the question. And what's the tangent line equation? Okay. Okay, in chapter 2, we have not covered the derivatives yet. If we knew the derivatives, then this would be easy, but we don't know the derivatives, so we are going to look at the rate of change. Okay, do you remember this ratio, f of a plus h minus f of a over h? Okay, this is the rate of change formula. We are going to use that. So this is our f. So, and our point A is 4. This is 4. Okay, and so -5, -9, 4 plus h squared minus -5, -9 times 16. Okay, all over h. So what you're going to do, you're going to simplify it. I have -5 here. Let me use the red color here. Okay, I have -5 here. I have -5 plus 5 here. Okay, they are going to cancel. Okay, because of this negative here, they cancel. This is going to cancel with this. And what is left, okay, is as follows. 9 times 16, I take this in the front, minus 9 times 4 plus h to the second power over h. Okay, so I have 9's common, so I'm going to factor this out. I have 4 squared, this is the difference of 2 squares, if you like, over h. Okay? All right. Okay. If you want, you can take a screenshot. I'm going to go to the next page. Okay? All right. So next page, the ratio is 9, 4 squared minus 4 plus h squared over h. Now, this is the difference of 2 squares. You know that a squared minus b squared is equal to a minus b. Okay, we know how to expand it. This is how you would expand it. Then let's go continue here. It's just a note. Okay, let me put it in red like this. Okay, and then I'm going to apply it 9 over h, 4 minus 4 plus h, four plus h. Okay, here you would see this 4 cancels with this 4. Okay, and then I have h left here. Okay, this becomes only h, negative h actually, right? This is going to be negative h. And h, I'm going to cancel the h with green one. Negative h cancels with h, and I have negative 1 left. Okay. Then, let me continue with the blue here. So I'm going to take this down here. Okay, this expression is equal to negative 9. Okay, 8 plus h. Okay, I got that. Now, I'm going to build a table for h getting close to 0. And then from here, actually, you don't have to do it. The reason is the values as h approaches to 0, this is going to be all getting very close to negative 72. Okay, you can either build a table, there's h, and then the corresponding negative 9, 8 plus h. Okay, and I mean, when you put numbers like very close to 0, like 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, etc., you are going to see that these numbers, and at 0 actually, negative 72. The table is going to tell you that these values are going to get very close to negative 72. This is going to be the value of the slope. Okay? Okay? Later on, we are going to learn that this is, okay, later, we are going to define the derivative like that. Okay, we are going to define the derivative. I'm telling you now, we are going to get to it, but I'm telling you now, we are going to use that definition, this fa plus h minus f of a over h. Actually, so far, in chapter 2, we only know this. Okay? And by taking the limit of this, you're going to get, we are going to define the derivative like that. Actually, the slope is the same as, slope at a is the same as derivative at a. We will see that, okay, soon. Okay, so let's get back to the question we had. All right, this is just an extra information, okay, extra. We will see this when we work on chapter 3. All right? So that's why working the limits is very important. All right? So that's why what did we do so far? We just looked at this and we said that let's go back to the previous page. Let's make h very small and gets close to 0. And you just build a table and you will see these numbers that are close to this is going to get close to negative 72. Okay. So then from this table, we are going to say we usually show the slope as m. Slope as 4, right? Because we are evaluating everything. So the question was this at 4, the point 4. Okay, x value. Okay, slope at 4. So m is the slope at 4, and we found that it's negative 72. Okay, now let's write the tangent line equation. Tangent line equation, as you would know, and remember, recall the point P. What was it? 4 to something. Let me go back to it. 4 to negative 149. Okay, 4 to negative 149. Okay, so you remember this formula, right? Y minus y0 is equal to m times x minus x0. This is the slope. These are the points P. Okay, so we just write it. Y plus 149. Because minus 149 makes it plus. Negative 72. And then x minus 4. That's our final answer. I'm going to put it in a box. This is the equation of the tangent line to the curve at the points 4 to negative 149, and we are done. Okay, any questions, Tülin? Or anybody else?
No question, teacher.
Okay, Yusuf, you go ahead. What's the question, Yusuf? Yusuf, you have a question. Your hand.
Are you talking to me, teacher?
Yes, your hand is up, so I thought that you have a question.
No, it was by mistake. Sorry.
No, okay, no problem. Okay, let's get back to any other questions. If you don't have any other questions, I'm going to work on 12. Okay, let's go back to 12. Let's see. Okay, this is section 2, chapter 2, section 2, and they are asking about the limit as x approaches to negative 2 pi, square root of x plus 9, cosine x plus 2 pi. Okay? All right, so it says type an exact answer using pi as needed. So we have to write, we shouldn't write the approximate answer, we should write it explicitly, okay? I mean, containing pi. Okay, let's get back to our page. All right, so this is, sorry about that. This is question 12, okay? Still homework 2, I think. Okay, so, okay, the question is find this limit. Limit as x approaches to negative 2 pi and square root of x plus 9 and then cosine x plus 2 pi. All right. So what do you do when you're taking the limit? You can build a table, okay? Or for functions that's not going to cause any problems, like if they are not going to cause any undefinedness, etc., you just plug it in. Okay, we are going to plug this in because, first of all, what is negative 2 pi? Okay, let's try to understand it. Negative 2 pi is not in terms of radians, but this is, I mean, this is close to, you can consider pi in radians as 3 point something. 2 times 3, it's negative 6 something. Okay, negative 6.2 something. Okay, approximately. So when you take this and put it inside the square root, no problems, because negative 6 plus 9, it's still less than, it's still positive. So I'm going to plug this in. Okay, plug it in. Negative 2 expression in the function. Okay, limit. I mean, I shouldn't write this anymore. Maybe I can continue here. Okay, so it's going to be square root of 9 minus 2 pi. Okay, and then what is cosine 0? Cosine 0 is 1. Okay, so this is 1. So the answer is this. This is the answer. Okay, very good. Okay, any other questions? I want to get the questions from you guys because this is going to show me that you're working. Okay, and it's okay if you cannot do it. Okay, go back to chapter 2. Homework 1, you mean, right? Homework 1. Okay, get to it. Okay, so here, yeah, which question would you want me to do, Jamia? Question 3, okay. Okay, yeah, it says, I think we did such a problem before, but yeah, actually, if you, Jamil, if you watch my video, last Wednesday's video, we did this question. Okay, I want you to look at that video, Wednesday's video. Okay, it should say Wednesday in there. Okay, we did this question. I don't want to spend time on this again. Is it okay? Okay. Any other questions? Any other questions? Yeah. Yeah, please ask me questions. So I'm going to do chapter 2 again, because in chapter 2, I can solve questions in 2.4, 2.5, 2.6. Just ask me, please, very quickly. Time is running. First one, 2, I didn't understand first one. Sudenur, which homework? Chapter 2?
Chapter 1, teacher.
Chapter 1, okay. Chapter 1. Okay, we also did this, Sude, in...
Oh,
yeah,
sorry. Okay.
We did this, it is recorded, so you can find it there, okay? Wednesday's
Okay.
class, we did that.
Okay, teacher. Thank you.
Yeah, any other questions? Okay, come up with questions, please. So, homework 2, 14, 15, okay. Let me write this down. Homework 2, 14, 15, chapter 2, 17. Chapter 2, Tülin, which section? Homework 2, you mean? Okay. Tülin, homework 2, chapter 17, or homework 3? Okay, good. All right, let's do those. Okay, 14, 15. Let's do that. Okay, so let me write the question down here. Okay, this is similar to what we just did. Okay, the function is different. Do you realize, look, in the previous question we did the same. So we looked at the rate of change, this quotient. Okay, we just put in f, okay, f 2x plus h, and then we just took the limit. It is the same type of question, but I'm going to do it again. That's okay. Very quickly I will do that. But if it is, so it is very similar to this. Look. Okay, look, do you see this ratio? We just said, we just calculated, where is this? We just calculated this, fa plus h minus f of a. Okay, let me redo this for this one too. Okay, this is question 14, homework 2. Okay, f of x. So this time it doesn't say slope, okay? It doesn't say the slope, but what we are finding is the slope to this curve at the point x is equal to 3. That's what we are doing actually, okay? So let me do this for you. So limit as h goes to 0, f of 3 plus h minus f of 3 over h, okay? That's how you should do. And then let's look at this difference, okay? Let's look at this difference, okay? I'm going to do this down here and then put it up here, okay? I'm going to do this separately down here. F of 3 plus h minus f of 3 is what is this? F of 3 plus h is 2 times 3 plus h. I plug in 3 plus h for x minus 1. And then minus f of 3 is what? F of 3, 2 times 3 is 6. 6 minus 1 is 5. Okay? This is f of 3. Okay? And then I'm going to simplify it. So I'm going to distribute this over here. This is 6 plus 2h minus 1 minus 5. Okay? So this cancels with this, and the answer is 2h. So I'm going to take that 2h, put it up here. Okay, limit h goes to 0, 2h over h. Of course, h is gonna cancel, and the answer is 2. Okay, that's it. Okay, I think this is clear, right? All right. So next question. Let's go back to the screen. It was 15. Okay, it says 7 minus 4x squared is less than or equal to g of x, less than or equal to 7 cosine of x for all x. Find the limit of g. Okay, as x approaches to 0. All right, I'm going to do that now. Okay, I'm going to go back to my screen here. Okay, this is question 15, right? Question 15, homework 2. Okay. 7 minus 4x squared less than or equal to g of x, right? And then less than or equal to 7 cosine of x. This is true for all x. For all x. This is true for all x, all right? And they're asking you to find limits as x approaches to 0, g of x. I have a question for you. Does this remind you anything? Any theorems we have seen? Can anyone comment on this? Okay, so do you remember sandwich theorem? Sometimes it's called squeeze theorem as well. So this function is squeezed between or sandwiched between this function and this function. Do you see that? When you have a function squeezed between two functions or sandwiched between two functions, then, okay, we use sandwich theorem to find the limit. In order, okay, the sandwich theorem says, find the limit of this separately as x goes to 0. If they agree to each other, all right, then the function in between has to go to the same limit. That's what the sandwich theorem says. Okay? Therefore, I am going to find the limit of 7 minus 4x squared first. This is a polynomial. When you're taking the limits of the polynomial, you just plug in the x value. Okay? This is 7 minus 4 times 0, which is 7. Okay? And let's find the limit of this. Limit as x approaches to 0, 7 times cosine x. Trigonometric functions like this are nice, so we just plug it in. Okay? Cosine 0 is 1, 7 times 1 is 7. Do you see that they are the same? So this limit of this is 7, limit of this is 7, and the sandwich theorem says then the one in between has to have the same limits. So we are going to say by sandwich theorem, limit of the function in between, limit of g as x approaches to 0 has to be equal to 7. I'm sorry. Let me erase this. Sorry. Here. Yeah, I made a mistake. Okay, has to be the same, which is 7. Okay, we are done. We have to write this theorem. We have to name it. We have to, when we are solving it, we have to state that by sandwich theorem. The limit is like this. You have to say that, okay, in your writing. Okay, Tulin, is this clear? Everybody, is this clear? Clear.
I have a question.
Yes.
Okay, very good. Okay, let me, okay, probably I created this page. Okay, anyways.
Professor,
Yeah, go ahead.
how x squared becomes 0?
Just a second. Let me go back to here. Okay, when you plug in, okay, if you plug in 0 for x, 0 squared is 0, 4 times 0 is 0, 7 minus 0 is 7. Is this clear?
So all the time you make x 0.
Yes, we just, so 0 squared, 0 squared, yeah, 0 times 0 is 0. You just plug in the x value because the x value, x approaches to 0, right?
Okay.
So we put this value in here. Whatever the x goes to, we put it in here.
Okay.
All right?
Yeah.
Okay, let's open up a new page and let's go to the previous, question, chapter 7, question 17. Okay. Let's say, consider the function given below. Okay. This is a piecewise function. It is made up of two pieces. One piece is this piece. The other piece is this sine 1 over x plus 1 part. Okay. All right. All right. So whenever x is less than -1, it's a 0 function. Whenever x is bigger than -1, it is the sine 1 over x plus 1 function. All right. We can make it bigger for you if you like. Okay. This is like that. Okay. This is how it is looked. See, sine 1 over x plus 1 is oscillating when it comes to -1. It is going up and down, okay? Never stops. All right? Okay, so we can even put it outside maybe. Yeah, it is this graph. It is going up and down as x approaches to -1 from the right. Okay, that's how it is. All right, so let's go down here. Does limit as x approaches to -1 from the right f of x exists? If so, what is it? If not, why not? That's the question, okay? All right. So what is your answer? Can anyone say? Yes, it exists. This? No, because there is no real number to which the function's values stay increasingly close to as x approaches to -1 from the right side. Can anyone remember an answer from our last class? Because we talked about sine 1 over x. This is just sine 1 over x plus 1. Okay, if you don't, then I'm going to open up the page here. This is question 17, homework 2. Okay, so recall y is equal to sine 1 over x. This is what we learned first. Okay, so this is such a function. Okay, it's a function going up like this, and then as it gets close to 0, it's going up and down here. Okay, similarly from the left, it's going to get close to here, but it's going to go up and down here. It just infinitely many times oscillates. Okay, it oscillates as x approaches to 0. But our function in this question is different. Our function is this: y is equal to sine 1 over x plus 1. Okay, I have a question for you. This is when x is greater or equal to, strictly greater than -1. Okay, I have a question for you. How can I get this function from this function? I'm sorry. Should we shift it to the left or to the right? Can you remind me that?
Left.
Yes, we have to shift it towards left by 1 unit to get this new function, okay? So let me open up a new page. Yeah, so if you shift it, I'm sorry, my drawing is not the best now. Okay, if you shift it towards left by 1 unit, you're going to get this, look, it's gonna be going up and down, and then it's gonna oscillate here. Maybe I should put these dots here. Okay, it's going up and down, it never gets equal to or touches -1, okay? Oscillates. It is shifted graph towards left by 1 unit. So sine 1 over x plus 1 is a shifted graph of y is equal to sine 1 over x graph to the left by 1 unit. Okay, now we know how it is created. But how about the limit? Okay, let's talk about the limit. Limit as x approaches to -1 this time from the right. Sine 1 over x plus 1. Okay? Look, if a function oscillates going up and down as it gets close to -1, it doesn't have a specific value. So we are going to say this limit doesn't exist. DNE. I'm sorry. DNE. DNE means does not exist. Does not exist. Okay, because it's oscillating. Whenever you have a graph that's oscillating, okay, you should say it doesn't exist. Okay, DNE. Do you see that? Does not exist. You can write this in short. So what's going to be the answer in that case? Okay, let's open it up. So we are going to say no, because there's no real number to which the function's values stay increasingly close as x approaches -1 from the right side. Let's check the answer. Well done. Okay, let's move to the next question. B, does limit as x approaches to -1 from the left, does it exist? If so, why? What is it and why? What is the answer? Can anyone give an answer to this? Are you with me?
0, teacher.
That's right, that's right, that's right. It's a 0. Okay, let's check the answer. Because it's all 0. Look, from the left, it takes only one value, which is 0. Look at that. Okay? Okay, we got a good job. Okay, C. Does the limit x approaches to f of x exist? If so, what is it? If not, why not? What do you think the limit at -1 exists? Does it exist? Can I get it? The answer is yes. The answer is no, because the left and right limits are not equal. So the answer is B, right? In order to have a limit exist, the right limit and the left limit, they have to agree, but this time they don't. Okay? That's it. All right. So any other questions? I'm gonna move to here. Okay, question 17 we did. We got check here. Okay, any other questions you may have? Did you write anything in the chat? Okay, Jamil, 4 in homework 2. Is that true? Okay, 4. Okay. Is this a question, Jamil?
Yeah, professor.
Okay. Which of the statements A through I about the function y is equal to f of x graphed here are true and which are false? What is A? The statement limit as x goes to 2 does not exist is true or false. Okay, let's look at 2. At 2, let's look at the limit. What is the limit here? Does it exist or not? Can anyone say?
Exist, teacher.
Huh? What's that?
Exist.
Okay. Because we look at the right limit, we don't care about the function being defined at 2. Okay, here it is defined, but it is defined different. Like instead of 3, it is defined 2. No, we don't care about that. We just care right limit and left limit. The right limit is 3, the left limit is 3. They are all equal to each other, so the limit exists. It doesn't exist, false. Let's check the question. We got fantastic. Okay, next part. The statement as x goes to 2 does not exist. The statement x goes to 2 is equal to 2 is obviously false, right? Because it is 3. It's not 2, it is 3. The statement goes to 1 does not exist is true or false. At x is equal to 1. Let's open this up. We are looking at 1. 1 is here. So what is the right limit? Can anyone say? At 1. Right limit is?
0.
Right limit is 0 because the function is going down, 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 down and becomes 0 here. And the left limit is?
-2.
That's right. So the right limit and left limit, they don't agree. So we are going to say the limit as x approaches to 1 does not exist is true. The statement limit as x goes to c f of x exists at every point c in -1 and 1. Let's look at -1 and 1. -1 and 1, it says for each point the limit exists. Do you agree or not? -1 and 1. So let's choose this point, for example. See, right limit, left limit exists. If you choose this point, right limit, left limit exists, and equal to each other. Choose this point, right limit, left limit exists. So we are going to say, for any point in between -1 and 1, the limit exists at every point is true. Okay? The statement limit as x approaches to c exists at every point c in 1 to 3. I mean, at every point c in, 1 to 3. Let's look at 1 to 3 here. Okay. What do you say? We are going to look between 1 and 3. Does the limit exist for each c in between? Which one doesn't exist? For which c, the limit doesn't exist then? Can you say, if you're saying false, then you should tell me a point that the limit doesn't exist.
The 2, teacher, 2 point.
But at 2, the limit exists. Because if you approach from the right, it is 3. If you approach from the left, it is 3. So the limit exists. Do you understand?
Yeah.
You just said that. Okay. So we are going to say this is true. Okay. What you're saying is continuity. We are not talking about the continuity, okay?
Okay.
The statement f of 1 is -2 is f of 1. Let's look at f of 1. F of 1, where is f of 1? This is 1. Is f of 1 equals to -2 in the picture?
No, 0.
It is 0. Yes, this is false. Okay. The statement f of 1 is 0 is true. The statement f of 2 is equal to 3 is f of 2 is equal to 3. Is this correct?
No. Is
False.
this true?
Yeah, that's right. Okay. The statement f of 2 is equal to 2 is correct. Okay. Any other questions you want to ask me? Okay, if this is all done, then I'm going to skip to the next homework. We have 2 minutes actually. We can take a break, and then we can come back to here in 10 minutes. Is this good? Let's take a break and come back in 10 minutes. So we are going to meet at 9:58. I mean 58, right? Yeah, 9:58. And think about the questions that you want me to solve, okay?
Hocam bir şey sorabilir miyim? Ama
Tabii
Türkçe
ki.
sorabilir miyim?
Tabii ki.
Bu salının fonksiyonunda yaptık ya hocam. Onun gerçek hayatta nerede görebiliyoruz? Yani böyle bir şey var mı açıkçası?
Tabii ki var. Yani elektrik elektronik mühendisliğindeki öğrenciler kullanabilir. Matematik derslerinde çok fazla önünüze çıkıyor. Ya matematiğin her dalında çıkıyor bu tür fonksiyonlar. Yani şu an direkt olarak aklıma application gelmiyor ama bu tür işte tanımsız olan, mesela biz benzer bir fonksiyon üretebiliriz. Kosin 1 over x. Kosin 1 over x de mesela öyle sıkıntıları olabilecek fonksiyon. Böyle sığınımları olabilecek fonksiyon. Yani çok fazla biz üretebiliriz. Var bunlar ve kullanılıyorlar.
Anladım hocam.
Hı hı.
Tamam. Teşekkürler. Sağ olun.
Hı hı. Let's meet at 10. Okay? Meet at 10. Okay, let's start talking about other questions. Let me check whether you guys have any. Let me see. Yeah. So we are going to start again. All right. So yeah. Now let's start again, and I want you to tell me some questions to solve. Okay. Okay. We can solve a couple of questions in homework 3 if you haven't started yet. Let's see. Just to let you get going. And I can extend the due date if you like for this. I think the due date is 27, it says. Why is that though? Okay, let me change. Okay. This is, yeah, you still have time for that, yeah. But I'm going to solve some questions for you to start with. 15 questions. Yeah, let's choose one of them. Let's start with the question 1. Okay, so these are one-sided limits. Okay, use the following function in this graph to answer parts through A through D below. This is a function f of x. This is a piecewise function. It is made up of pieces here. Okay.
Professor, we can't see your
Teacher,
screen.
I can't see anything.
Okay, thank you. Thank you. All right. Okay, that's the question. This is the first question in chapter 2, section 4. You are given this piecewise function. It has 3 pieces. First piece, second piece, and third piece. And this is drawn in the picture. Okay, let's see the picture bigger. Look, until 5, it is 7 minus x. This is the line. At 5, it is 3. The value is 3. And after 5, the value is, the graph is 2x over 5. Okay? See, there are 3 pieces. First piece, second piece, and the third piece. So there are 3 pieces. And the question is, find limit as x approaches to 5 from the right. So we want to find the limit from the right. Select the correct choice below. Fill in the answer. So what is the limit here if you approach from the right? Can anyone say?
2.
It's just 2. It's easy. So we are going to say it exists and it is 2. We got it right and check the answer. It's good. And next, find the limit from the left. Select the correct choice below. Fill in the answer. So this is again 2, right? Because in the picture, if you approach from the left, it is 2 again. Let's continue. Okay. And then any other. Find f of 5. Select the correct choice below. If necessary, fill in the box in your choice. So if you open this up, at 5, the value is 3. Look at that. The value of the function at 5 is 3. Look, it is 3. So it's not 2 at all. So we are going to say f of 5 is 3. Okay? Check the answer. Okay, does f of x as x approaches to 5 exist? If so, what is it? If not, why not? Okay, so what is the answer? Can anyone tell me the answer?
Yes, it's 2.
Which one?
B.
B, yeah. The answer is B, and it's equal to 2 because right limit and left limit exists. That's good. And then find the right limit as x approaches to 2. Select the correct choice below, blah, blah. Okay, let's open up. this is 2. What is the right limit if you approach from the right? At 2.
5.
It is 5, obviously. Okay, so this is easy. This is 5. These questions are easy. And now find the limit as x approaches to 2 from the left. It is 5 again. Okay. And does the limit as x approaches to 2 exist? Yes, it exists because right limit and left limit are the same. Yes, and it was 5. Check the answer. Okay. Next question. Let's find a difficult question. Let's go to the next one. This is similar. Okay, do you want me to do this or you can do this? I think you can do this. Do you want me to do this or you can do this? Let me do this because I didn't do such a thing before. Let me do that. Okay, let me write this down so that we can use it. Or if you can do it, you can also solve it and show it to us. Okay? In the screen, in your camera. Okay. So let's open up a new page. All right. This is homework 3, right? Is it homework 3? Homework 3, right? And question, I don't remember. Question 4. Question which one? Question 4, yeah. Okay. Okay, so the question I have written, so they are asking you to find this limit as theta goes to 0, okay, tangent theta and theta squared, okay, cotangent 6 theta. Okay, that's what they want you to find. But we are going to use sine theta over theta goes to 1. Okay, we are going to use that. So how should I start? So I am going to, okay, I am going to write everything in terms of sine and cosine. Okay, before I do, actually, this cotangent 6 theta, what is this actually? Let's work this here, 6 theta, okay? This is cosine 6 theta over sine 6 theta. Okay, this is it. All right. So keep this in mind. So I'm going to tangent theta, you know that sine theta over cosine theta. And cosine 6 theta is cosine 6 theta, theta, sine 6 theta. Okay? And then I have 1 over theta squared here, times 1 over theta squared. Okay. Now, if you see, cosine 0 is 1, no problem with that. And cosine 6 theta is going to go to 1, no problem with that. But the problem is, theta goes to 0, this is going to go to 0, this is going to go to 0, this is going to go to 0, and this is going to cause us that this thing is 0 over 0. And 0 over 0 is not good. Okay, 0 over 0 is undefined. This is undefined. So we have to do something. Okay? Okay. Okay, limit as theta goes to 0, what I'm going to do, sine theta over theta, okay, sine 6 theta over theta times 1 over cosine theta, just a sec, 1 over cosine 6 theta. I separated them all, and I put this theta squared underneath these guys. Okay, so I know this is gonna go to 1 as theta goes to 0. However, this one I don't think it is possible. I'm gonna play a trick here. Look, I'm gonna multiply and divide with 6. And then, now, this thing is gonna go to 1 as well. Okay, and then this is gonna go to 1, and this is gonna go to 1. Okay, so then what? Okay, what's my answer? Can anyone say? Can anyone say the answer? 1 times 6 times 1 times 1 times 1. So this is 6. Okay, this is the answer. Okay, did you see the trick that we played? I mean, we did a trick here. Any questions about this solution? Okay, can you hear me?
Yes, teacher.
Is this clear?
Yes.
Teacher, can you repeat the part that
Okay.
you equal everything to 1?
Okay. So from here, you understand this part, right? It is 0 over 0.
Yes.
Okay, then I want to just take this theta squared and distribute it under and put them underneath sine theta and sine 6 theta. Look, I took the 1 over theta squared and put it underneath and put it underneath. And then I separate 1 over cosine theta. I moved here and 1 over cosine 6 theta here. And I know sine theta over theta is 1. We showed this before. I mean, we talked about this before. Sine 6 theta over 6 theta. So this is sine 6 theta over theta is not very good. We have to have 6 theta underneath to make it sure that it's going to go to 1. So we just multiply with the numerator and the denominator with 6. So the value doesn't change. The value of this expression doesn't change. Because if you multiply an expression, numerator and the denominator of that expression by the same number, the value doesn't change. That's the trick. And then we just gather these together, and this is going to go to 1. Sine 6 theta over 6 theta goes to 1. And this is 1. This is going to be 6 times this is 1. And this is going to be 1. And this is going to be 1. So it is 6. Is this clear, Emir? Was that you?
Yes, thank you, teacher.
Okay. All right. Let's move on. Okay. Let me see. We did the 4, just a sec. Let me check 5. Okay, this says find the following limit. Is the function continuous at the point being approached? Just 1 sec. Okay, I'm back with you. Let's see. Okay, find the following limit. Is the function continuous at the point being approached? Okay, so this is the function, cosine pi over square root of 11 minus 2 secant 3t, and t is approaching to 0, and they want you to first find the limit, and then they're asking, is this a continuous function at that point? That's the question, okay? So let me write this down, and then cosine pi square root of 11 minus 2 secant t, and then t goes to 0. Okay, let's go back to our screen. Okay. Homework 3. Question 5, yeah. Okay, so they're asking you to find this limit. Limit t goes to 0, cosine. If you get the answer, let me know, okay? If you have any guesses, you can talk. Okay, so first of all, this secant t, what is secant t? Secant t is equal to, what is secant t? Can anyone tell me? Secant t is 1 over cosine t. As t approaches to 0, this is 1, okay? If this is 1, 1 times 2 is 2, 11 minus 2 is 9, square root of 9 is 3, cosine pi over 3 is, cosine, we have to find it, cosine 60, which is sine 30, which is 1 over 2. So we got the answer. So what is, so what is secant 0? Secant 0, 0, this is 0. 1 over cosine 0, which is 1. Then, actually, because of this, we can put in the value. So we don't have any undefined. So we are going to say this is equal to cosine pi over 3. Okay, this is the same as sine pi over 6, which is 1 over 2. Okay. And the function is actual, this function is continuous at t goes to approaches to 0.
Samuel teacher, your screen is frozen. We can't hear or see anything.
Şarj bitmiş olabilir.
Okay, unfortunately, my computer restarted itself. It's not the internet connection problem. Sorry about that. I think charging issue because of the charger. Okay, we are going to continue now. Okay, sorry about that. Let me check whether it is recording. Yeah, it's recording. So we are going to continue. I don't know how much of it you heard of me, but I'm going to repeat it again. Okay. Okay, so let's see. Can you hear me now?
Yes.
Okay.
Yes.
Sorry about this break. We will continue right now. Yeah. I have to open this up again. As it opens up. Okay, so did you understand this question, question 5 in homework 3? This is a continuous function because we don't have any undefined situation when t approaches to 0, and it has a well-defined limits, so everything is fine. Maybe we can add that here. Let me see, where's my pen? Okay, so okay, let's call it f of t. F of t is continuous, okay, at t is equal to 0, because at t is equal to 0, no problem. We don't observe any problems in here, right? We got 6 here, so no problems with that. let's go back to here. Okay, let's see. Question 5 is over. Let's see question 6, what it says. Okay, this is a good question. I want to talk to you about these questions, these type of questions. So sometimes given function is not continuous at a given point. But what you could do is you can extend it in a way that you make it a continuous function at a certain point. So in this question it says, what should we assign f of 2 to make the extended function continuous at x is equal to 2? For example, let's say at 2, the function is not defined, right? We want to make it continuous at 2. So, but the new function that we are going to define by extending the current function is a new function. It's not this anymore. Okay, we are going to call it g. Continuity requires that three things. Continuity requires three things. One, the function has to be defined at that point. Two, right limit, left limit exists, and so that the limit as x approaches to exist. I mean, maybe I should say it like that. First, the value of the function. This is the continuity test. Continuity test says the function is continuous at 2 if number 1, f of 2 is defined, which means f of 2 has a finite value. Number 2, f has a limit at 2. Number 3, f of 2, the value of the function at 2 has to be equal to the limit of the function at 2. So this is our continuity test, all right? So this is saying, I want you to first look at that. At 2, it is not continuous. Why? Because it is not defined at 2. Does this has a limit? Does this function have a limit at 2? Can you tell me the limit at 2? Does it have a limit at 2? And what is the limit if there is? Can anyone say?
2.
That's right. The limit at 2 there is a limit. At 2, the value of the function is not defined. So we want to make it continuous. So we are going to extend the whole function to a new function. We call it extended continuous function. Its name is extended continuous function by defining f at 2 as 2. Okay? So we are going to say the answer is, if you define the function at 2 as 2 as the limit value, then this is going to give you an extended function at 2. Okay? This is question 7. Use the graph to answer the question about discontinuity. Okay? Select the correct description of the continuity of f at x is equal to -2. Okay, let's see. At -2, what happens? At -2, do you see that we have a discontinuity at -2? Discontinuity means it's not continuous at -2. Do you see that? And which part of the continuity test failed at -2? Can anyone say? Which part, what is failing in continuity test so that this function is not continuous at -2? We had 3 conditions. 1, it has to be defined at that point. Number 2, the function has to have a limit. And number 3, the limit of the function at that point has to be the same as the value of the function at that point. This is continuity test. And here, as you will see, at -2, the value of the function is not defined. So that's failing, okay? So let's just select the correct description of the continuity of f at x is equal to -2. There is a discontinuity that can be removed by defining f of -2 as 0. Do you agree with that? There is a discontinuity that can be removed by defining f of -2 equals to 0. Is this correct? Okay, probably you didn't study these parts, that's why you cannot answer. So whenever actually, this is the correct one. Why? Because if at -2, you define, because at -2, the limit is 0. If you define the value of the function as 0 in here at -2, then the function becomes continuous. You don't have any gaps here if you do that. Okay? So I hope you're hearing me. Can you hear me?
Yes.
Okay, good. Okay, let's. All right, good. Sometimes I need confirmation because otherwise I don't feel good. Okay. So the answer is this. Can this be right? There is a non-removable discontinuity because f of x2 is not defined at x is equal to. Take the correct description. Okay, I'm sorry, correct description. We are not finding extended. I'm sorry. There is a non-removable discontinuity because f of x is not defined at x equals to -2. This is not right because why? There is a removable discontinuity, not non-removable. Non-removable means you cannot extend it to a continuous function. Okay? Removable discontinuity means you can remove the discontinuity and make it continuous function. Okay? So A is not. So A is okay. There's a discontinuity that can be removed by defining f of -2 as -2. That's not right. So the answer is A. There is a discontinuity that can be removed by defining f of -2 is equal to 0. So this is the correct answer. The last one cannot be right because the limit is 0. It's not -2. So this is the right answer. Okay. Next, at what points is the following function continuous? The function is continuous on, we have to say, okay, at what point? So we have to type your answer in interval notation. So probably the function is continuous more than 1 point. Okay, they want us to write it in. Let me do this in the other page. Okay, let me copy this question down. F of x is equal to x squared minus 2x minus 8 over x minus 4 and 6 whenever x is 4. And otherwise, it's the other one. Okay, so let me go back to our page. Okay, and this is question 8. Okay, question 8, homework 3. Okay. I'm sorry. Okay, so let's write the question here. F of x is equal to, it's a piecewise function. Look, it has two pieces. X squared minus 2x minus 8 over x minus 4. Okay, x is not 4. And it is 6 whenever x is 4. Okay. The question is, find the points where f of x is continuous. So find the points where f is continuous. Okay. All right, this is a nice question. Okay. Solution. Okay, so first of all, I want you to just focus on this first piece. So we have x squared minus 2x minus 8 over x minus 4. So I want to factor this out. Okay, so this is x minus 4 on top and x plus 2 on top and x minus 4 in the bottom, in the denominator. Okay, is this the right factorization? Yes, it is. Okay, and do you observe that? Okay, do you observe that we can actually, these are the same, and actually if I want, I can cancel these And I'm going to get, if I cancel them, I get x plus 2. Okay? So why did I do that? First of all, I can only cancel them. There's a rule, okay? When you wanna cancel two factors like that, you can cancel them when x is not 4. Okay? Because if x is 4, this is 0. This is 0. You're not allowed to cancel. Okay? When x is not 4, you can cancel. And it says in the question that it is this when x is not 4. So then I can cancel them. I'm allowed to cancel them. Actually, this part is the same as x plus 2. Okay? It behaves the same. And then at x is equal to 4, they define it as this green color, which is 6. They define it 6. We have to check whether at x is equal to 4, this is also 6. If you plug in x is equal to 4, do you get a 6? Yes, you do. Okay? So the way we are going to do, we are going to take the limit. Okay, limit as x approaches to 4. Okay, which is x squared minus 2x minus 8 over 4. Is this equal to 6? That's the question. If this is 6, then the function is continuous at 4. Okay, let's check it again. This is our claim. Is this really 6? Okay. Solution. Okay, limit as x approaches to 4. I'm going to factor this out as this should be x minus 4, I'm so sorry. X minus 4, x plus 2 over x minus 4. Since here x is approaching to 4, x is not 4, okay, you can cancel them. You're allowed to cancel them. So this, you can cancel them, okay, so this is equal to limit as x approaches to 4, x plus 2, and this is a polynomial, yeah? When you have a polynomial, you can directly plug in the value, polynomial, for the limits. Okay, plug it in, you get 6. We really get 6. This is going to tell us that if you go back to maybe here, let's see. Okay. So they were asking about this function being continuous or not. We just checked around 4. So when x is around 4, this is 4. When we approach 4 from the right and the left, the function is behaving like 6. And they define it at 6 as well. So this is going to tell us that at 4 it is really continuous. Okay? All right. So we are going to say that, let's go back to it. And new page. Not that. Okay. Okay. New page. So I'm going to draw the graph of that. Okay, let's write the result first. F of x is continuous. At x is equal to 4. Okay, I'm going to draw the graphs now. Indeed, let me finish this my sentence. Indeed, f of x is continuous everywhere. Is continuous for all x. Continuous for all x. For all x. For all x means on. So you're going to write the all x, namely, it says in terms of intervals, right? Negative infinity to infinity. It is continuous everywhere. Okay? So we are going to write the answer like that. I'm going to show you in the picture, okay, why this is so. All right? So I'm going to draw the graphs of these. Graph of the functions. These two functions. X plus 2. x plus 2, when x is 0, it is 2. When y is 0, x is negative 2. Okay, this is the graph of the line y is equal to x plus 2. Okay. On the other hand, I'm going to draw you guys the graph of what was it? At 4, there's a problem, right? At 4. Okay. At 4, this is 6. Okay. Excuse me. The one on the right that I draw, it is the graph of this, by the way. Y is equal to x squared minus 2x minus 8 over x minus 4. See, this green one, the graph of this is this, empty here. Okay? This is the graph of y is equal to x plus 2. And if you want the graph of f, the graph of f is the one that this one is filled in. Okay? Which is this actually, x plus 2. Okay? So, at 4, if you fill this in, okay, you get f. F of x is the whole graph here, okay? So in other words, f of x is actually x plus 2 at the end, okay? But this one is just one piece, is not continuous at 4. Look. But we make it continuous by defining it. Let me go back to the function. Here, this is not continuous at 4, but we make it continuous by extending this function by defining it as 6, okay? So now f is continuous. So this is an interesting question. So I want you to understand this well, okay? These are the graphs, okay? Let me draw this. Maybe the red color is the f, okay? Let me draw the red color. Red graph is the f, okay? All right. Okay, we have 3 minutes. Let's go back to another question. Any questions about this question? This is a tricky one. Okay, this is tricky. Okay, where was I? Okay, what should we write here? We are going to write the interval like that, and here we are going to say minus infinity, excuse me, and here we are going to say plus infinity. Let's check the answer. Excellent. Okay. All right. So let's do the example 2, 3 minutes. Suppose that a function is continuous on the closed interval 0 to 1, and f is between 0 and 1 for every x in 0, 1. Show that there must exist a number c on 0, 1 such that f of c is equal to c is called a fixed point of f. Okay, this is intermediate value theorem. Okay, so let me see whether intermediate value theorem requires you f to be continuous on a closed and bounded interval like that. Okay, and you are given 2 values. F is between 0 and 1. These are f of a and f of b in the theorem. So this is intermediate value theorem. And it says there must exist a c. Yeah, c is between 0 and 1. So there must exist a c such that f of c is a fixed point. This is a fixed point theorem actually, this one that you're seeing now. Okay. Okay, so let's see. In which scenario is the proof trivial? You have to study the intermediate value theorem for this. So I'm going to skip that for a little bit because you have to study and understand that. Okay. I'm not going to give you right away the answers. Okay. So let's leave it at that. But this is the fixed point theorem actually in real life. There's a theorem that is named with this name. Okay. I'm going to skip to another question that's going to be easier to understand for you. Using the graph of the function f, evaluate the limits a through I. Okay, select the correct choice below and fill in the answer box within the choice. So what is the limit? They're asking the limit as x approaches to 4. Let's see. As x approaches to 4, you can make it bigger. Okay, as x approaches to 4, it is negative 4. Yeah, look at that. You approach from the right and left, it's negative 4. Okay, so we are going to write that, negative 4. Okay, it exists. Let's check the answer. Okay, and then what is the limit as x approaches to negative 3 from the right? Negative 3 from the right. Let's look at that. Negative 3. Where is negative 3? Negative 3 is here. What is the limit from the right? Can anyone say? Which one? What's the limit from the right?
-5.
That's right. That's right. So it's going to be -5. Okay, check the answer. Nice work. What's the limit from the left? It's going to be, let's open this up again. From the left, it is 3, right? 3. Okay, and almost done. Select the correct choice below and fill in the answer. Limit doesn't exist or exist?
Does not exist.
That's right, because the right limit, left limit, they don't agree to each other. How about the limit of as x approaches to 2 from the right? Let's see. We are going to approach to limit at 2 from the right. It is -4, right? -4, let's put it in. -4. Did you guys all see it? I'm not sure. Okay, and as x approaches to 2 from the left, let's open it up. As x approaches to 2 from the left. What do you think the limit is?
Infinity.
That's right. Plus infinity. Okay, let's check the answer. Okay. And then select the correct choice below and fill in the answer box within the choice. X approaches to 2 does not exist because right limit, left limit, they don't agree. This was an easy question. What is the limit as x approaches to infinity? What do you think it is? As x approaches to infinity, where does it go to? It gets very close to
-2.
-2, perfect. -2. -2 is good. Okay, well done. And as x approaches to -3, let's open this up again. Negative infinity, I'm sorry. Negative infinity, x is approaching to -1. Okay, -1. All right, check the answer. Okay, next question. I think time is up. Next time. And yeah, the questions that's going to appear in your homework, they may be different. The functions could be different. So I'm solving homework just to motivate you in working for this class, and do the homework and prepare a handwritten version and upload it onto the Teams or LMS, and that's it. That's all I want you to do, okay? Thank you very much. Do you have any questions in general?
Hocam aslında var benim. Bu Wolfram Alpha'da da çizseydik bu şeyi. Limit söylesem polynomial function. Onu aynısını çizseydik yine biz sürekli der miydik?
Şunu mu? Pardon, gösteremiyorum galiba. Bir dakika şey yapayım, share edeyim size. Yani, parçalı fonksiyon diyorsunuz değil mi?
Aynen hocam, aynen parçalı fonksiyon.
This one you're talking, let me open this up. This one you're talking, right? I mean,
I can't see.
let's see.
Okay, yes.
I'm not that. This one you're talking about, F, question 8. You mean question 8, right?
Yes, teacher, yes.
If you draw on Wolfram Alpha piecewise functions, give it a try. If you can draw the graph of piecewise functions, you should be able to draw it. But see, I mean, Wolfram Alpha has a version which you pay and you see it more clearly, the graphs. The free version doesn't really show the details as much. Okay, so sometimes you may get into trouble because of that. Okay, so I don't want you to buy the product. The free version should be enough for Calculus 1. But be careful when you're working on Wolfram Alpha. For some details, it doesn't show clearly when it's drawing the graphs. Did you try to draw this on Wolfram Alpha?
Yes, teacher. Actually, I have some problem. Yes, as you say, as you
Yeah. Be careful about Wolfram Alpha. So, otherwise they wouldn't earn money, right? They would just. You understand?
Yes.
So yeah, double check your work on Wolfram Alpha and what you are doing as well. Okay.
Yes.
Thank you, teacher. Thank you very much for the comment. What's your name? What's your name?
Ömer, teacher.
Ömer. Okay. Ömer Faruk. Okay. Now I see your name. Okay. All right. Maybe there are some other questions here, or maybe buys. Yeah. You can say bye, and we. I'm gonna just get the attendance sheet here. Let's see. Yeah. Okay. Take good care. If you have any other questions, I can stay a little bit and I can answer your questions. Otherwise, I'm gonna just stop the recording, etc. You can ask me general questions as well, like especially new students, they can ask me questions. I can answer their questions right now so that they are not behind. Okay, if there are no questions, take good care, guys, and see you next time. Okay? Aisha, do you have a question?